Hello gamers! Welcome to the next section. No one is alone forever. In this section, we will first create a shooting system by creating player and enemy controller. Then implement a basic AI enemy. Instantiate game objects such as bullets. And finally, make game objects auto-destruct. Now we move on to the first video of this section, player controller. In this video, we are going to first look at the requirements, then write a script to move the player and give the ability to shoot. Let's start by defining the requirements for this player controller. First of all, we would like to lock the movement to only left and right. Another consideration is that the left and right movements are limited. The player cannot go off screen. In Angel Cakes, we have solved this problem by placing walls. In space, there are no walls, and even if we could place invisible ones, for the sake of learning and something new, we will see how to limit the movement through the script. Differently from Angel Cakes, the player here can shoot. In particular, the player can shoot straight from the player's location. In our implementation, this means that the player controller has to instantiate a bullet. However, we also need to limit this process, since we don't want the player to shoot billions of projectiles per second. Lastly, the spaceship can take damage, so we need to show the animation of the explosion where the enemy's bullet has hit the player. Actually, not only should it show the explosion, but it should also play a sound and decrease the number of lives by 1. Now that we understand the requirements for our player controller, let's implement it. First, we will create a player controller script. Inside the script folder, right-click, and then Create. Then select C# script. We name it Player Controller. Now the script can be used as a component. We then open the script, and you will see this code. At the beginning, there are 3 lines that allow us to use libraries. Then there is the class definition, in this case named Player Controller. Inside it, there are 2 functions, Start and Update. The first is called every time this script starts, whereas the second is called at every frame. We will now learn to move the player. Let's start by copying and pasting the code from section 3, Let's make some prefabs. In fact, we need to enforce both collider and rigid body components, since we will use them to move the character and also to detect collisions with bullets or enemies. The final code should look like this. So far so good. The player is able to move left and right. However, the spaceship's movement is unlimited along the x-axis. Therefore, we will need to use a wall to contain the player's movement. To begin, we need to add a variable. We assume that the main camera is centered, as in any 2D default scene. Thus, if the player is on x equals 0, then the spaceship is in the middle of the left and right sides of the screen. As a result, we were able to use just one variable to limit the motion both left and right symmetrically. We can add to our code the bound x variable, make it public, and assign an initial value. Now within the fixed update function, we need to use a math function to clamp the x value in case it becomes bigger than bound x or smaller than negative bound x. So we add this line. In the Unity math library, such a function is already implemented, so we use it between getting the new x value and assign the new position to the rigid body. Save the script and test it to see if it works before moving on. The next step is to give the player the ability to shoot. In doing so, the player controller creates a bullet prefab. We don't have a bullet prefab yet, but we will create it later. However, we can create a variable to hold the prefab, so it can be changed later on in the inspector. So add the bullet prefab. Now in the fixed update function, after all the lines we already have, we need to instantiate the bullet every time the player shoots. For this, we have added this code. In this case, we check whether the player presses the Fire 1 button or the E key. If so, We just instantiate the bullet prefab at the same position as the spaceship and without any rotation applied, which is expressed through the admittedly fancy quaternion identity argument. You can find out more about quaternions in Unity at these links. This works just fine, but it can be improved. As we anticipated, right now the player can repeatedly press the E key and can shoot many bullets. We want in some way to limit this process. In order to achieve this, we need to write a bit more code. First, we add two variables to store the reload time, which is how often the player can shoot, and the last time the player has shot, which is a private variable to check if the reload time has expired. We have to change the code in the fixed update to reflect this change, so inside the if statement, we add this code. This code is used to check if the player has shot, and we nest another if to check whether the player can shoot or if it is too early, the reload time hasn't expired yet. We do this by calculating with a subtraction how much time has passed since the last time the player shot, and compare it with the reload time. If this results as greater than the reload time, then we need to update the last time the player shot and actually created the bullet. In the last section, we created an explosion prefab. This will come in handy now when we need to make our spaceship explode every time it takes damage. If you remember in our last game, when the player comes into contact with a cake, it is collected. This was done using a special Unity function named onTriggerEnter2D. Here we are going to do something similar. We will implement the explosion in this way. When the enemy bullet hits the player, first of all, I add a variable that holds the explosion prefab, so we are able to instantiate it in the hit function. Then I add the hit function with a line of code that creates an explosion based on the explosion prefab variable at the same coordinates of where the spaceship of the player has been hit. This means that the coordinates are passed from the bullet script as a parameter of the function. Save the script. And as a result, the spaceship is able to take damage, or at least show that it has been hit. We will deal with the proper damage in the next section 7. If you don't want to wait to implement the bullet script to test this function, you can add in the fixed update, so that every time the player presses the key T, the hit function is called. And this is how our game looks. We have used these aspects. This is our spaceship, and over it, we have the explosion. The background that you see here is also available in the package.